First test is p-series. So for p-series, it's basically in the form of 1 over n to the p. And so the p is the exponent, and p has to be greater than 1 for it to converge. And if p is less than or equal to 1, then it diverges. The one, if it's less than or equal to 1 is because the antiderivative of 1 over n is ln of n. And that, like, the limit of, as n approaches infinity, of natural log of n is infinity. So that's why 1 over n diverges in the series. So the next one would be a alternating series. And with the alternating series test, this is used for things like things in the form of -1 to the n times a to the n. So basically for this, you just have to take the absolute value of this and find out if that series converges. But if the absolute value of that diverges, but the normal version converges, then that's called conditional convergence. But if this converges, like the absolute value one, then that's called absolute convergence. Next one would be ratio test. So for ratio test, you take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. So to use this as an example, it's common to use it for things like 1 over n factorial or something like that. So if you do 1 over n factorial for this, you did limit as n approaches infinity of the absolute value of 1 over n plus 1 factorial over 1 over n factorial, which you can simplify to the limit as n approaches infinity of n factorial over n plus 1 factorial. And basically, n plus 1 factorial equals n plus 1 times n factorial. So if you do the limit as n approaches n factorial over n plus 1 factorial, you would just get 1 over n plus 1. So for the ratio test, the limit, if it's less than 1, like this one, the limit as n approaches infinity of the absolute value of 1 over n plus 1 equals 0. So that's less than 1. So this converges absolutely. But to diverge, it has to be greater than 1, the limit, or n equals infinity. Well, like limit equals infinity. If the limit equals 1, then that's inconclusive, and you have to use another test. Next one is root test. So root test is used for things like n to the n, or 1 over n to the n. So if you're going to use it for n to the n, you'd have to take the nth root of n to the n, and this would equal n. So if you take the limit as n approaches infinity of this, you would get infinity. So to diverge, the limit has to be greater than 1 or equal to infinity. To converge, absolutely, it has to be less than 1, the limit, And to be inconclusive, it has to be equal to 1. Same thing as ratio test. The next one would be telescoping series. This would be used for something like 1 over n plus, minus rather, 1 over n plus 1. So if you write out the terms of something like this, it'd be 1 minus 1 over 2 plus 1 minus 1 over 2 minus 1 over 3. So you take all the numbers in here that don't repeat. So for this one, that'd only be 1. And then you do that. You do all the terms that don't repeat, or the numbers. And then you do minus or plus depending on what this is. This thing. So that'd be 1 minus n plus 1. And you take the limit as n approaches infinity of this. So limit as n approaches infinity of 1 minus 1 over n plus 1. This would equal 1 minus 0, which equals 1. So for telescoping, well, that's actually the sum of the series. So it converges to 1. The next one would be integral test. So, there's a little saying that you can use to help you remember integral test. In prison, dogs curse. So basically, if a sub n equals f of n, if f of n is positive, decreasing, and continuous. Then the series and the integral of 1 to infinity of f of n dn either both converge or diverge. The next one would be the nth term test. So for the nth term test, you take the sequence of a series, which would be it'd go along the lines of something like a to the n or something like that. So if the limit as n approaches infinity of a to the n is not equal to 0, then it diverges. But if it's equal to 0, it could either converge or diverge. So you have to use a different test to know that. The next one is geometric series test. This would be used for something like r to the n. And r is the rate. So r would have to be less than 1 to, 0 is less than r, is less than 1 to converge. But if r is equal or greater than or equal to 1, then it would diverge, because it would just go to infinity. The next one would be the comparison test. Direct comparison test is one of them. So basically, you take something like n over n cubed plus 1, and you compare it to something similar, like n over n cubed, which equals 1 over n squared. And then the thing you compare it to has to be either greater than or less than the original function, depending on if the original function converges or diverges. If the original function converges, then the thing you compare it to has to be greater than the original function. But if it diverges, then the thing you compare it to has to be less than the original function. So the thing you compare it to, if it either converges or diverges, whichever one, then the original function either converges or diverges. The final one is limit comparison. And it's the same thing as direct comparison, but once you take the thing you compared it to, like 1 over n squared here, you do the original function with the limit as n approaches infinity, the absolute value of the original function over the compared function. So this limit has to be finite and positive in order for it to converge. But if it's not finite or not positive, then it will diverge.